students. Today we learn the deflection of a fixed beam subjected to UDL throughout the length by moment area method. Now this is the beam of length L meter is subjected to a UDL W kilonewton per meter, and suppose this support is A and this support is the B. The first step in this moment area is what? To draw the deflected shape. We know here at the support is slope is the 0, is the deflected shape. Now it's at center, suppose this point is the C. At support point is the C and this is the delta. This is the delta. So here by second theorem, what here we are drawing the tangent at C. And drawing the vertical line or deviation, measuring the deviation of that tangent with respect to the point B. So by second theorem we can say that TBC, deviation of a tangent drawn at C with respect to the B, that is equal to AX bar upon EI. And this height we can say that is this height is TBC, deviation of a tangent drawn at this point with respect to the B, that is a TBC, and that is equal to AX bar upon EI, and that is equal to the delta. That is equal to the delta C. So this is our first step. What is our aim is to calculate this TBC, that is the delta, that is equal to AX bar upon EI. So AX bar. Now here first draw the BMD. So we are drawing the BMD separately for the considering the beam as simply supported and drawing the bend moment diagram here. That we know if you consider the beam is simply supported, the diagram is a parabolic and this height is WL square by 8 and this diagram is positive. We know that due to the fixity, here is in this direction acting is the MA and that is WL square by 12. Also here is a fixed end moment here and that moment is WL square by the 12. So we are drawing the separate diagram for that. And both side intensity, both side the height is the same. So the diagram is symmetry, and this diagram is creating the hogging fixed end moments. This is creating the hogging, so that diagram is negative, and this height is WL square by 12 here, and WL square by 12 here. Now, what our aim is the TBC means what? Reference is our B. Moment of the area between this BC with respect to the B. This is the TBC, indicates that. So what here we have to take only this area. We have to take only this area. And what about the B? So this is X bar and this is the X bar. So now this we can say that is A1 X1 bar divided by EI plus A2 X2 bar divided by EI. So that is equal to nothing but is the delta C because both is the same. So that is equal to A1 X1 bar for this we know is 2/3. Formula is 2/3 base into height. 2/3 base is L by 2 into height is WL square by 8 into centroid of this from apex is what? 5/8 of this distance. This is the 5/8 of the, suppose this is high, this length is the L by 2. So this is 5/8 of L by 2. So 5/8 of L by 2 and this total is divided by EI. Then this diagram is minus, so sign is minus. Now the base is L by 2, height is WL square by the 12 into CG of this is what? L by 4, because total is the L by 2, so CG is the L by 4, so is equal to, now this 2 and 2 gets cancelled out, so this becomes WL square L and this is L, so this becomes 5 WL raised to power 4. Now this becomes the, what is here, 3 into 2 into 8 into 8, 384. So this is 384 minus W L square L raised to power 4 divided by 48 into 96. So here, if you do here these solutions, what here, this is 5u by 384 minus 1 by 96. So this is the, becomes WL raised to power 4 divided by 384. Here also total divided by the EI, because this EI here. Here also the EI, here also the EI, so here also the EI. Okay, so this is the delta C and delta C. In this way we got here the deflection at the center of the fixed beam subjected to UDL is WL raised to power 4 divided by the 384. Thank you.